Hello, today we are going to be performing get to emergency operation on this pure sine wave uninterruptible power supply from company called Volt. This is extremely interesting model, and that's because it was designed to provide power for your critical load, but in compared to your regular UPS, that model is designed to provide that power over a long period of time. And this is extremely interesting characteristic because it is 800 volt amp, but it contains 55 amp hour battery. So it's got extremely high capacity if you compare it to the output power that it can provide. And you can clearly see that it was a low power unit, but designed for a long period of time. And this is a very interesting characteristic because most of your regular computer power supplies are designed to provide power for like 7 to 15 minutes at full load. And to get longer runtime on like a low power unit, you have to purchase model that is going to be get much more volt amps, and you are paying and getting much bigger unit instead of just getting a bigger battery. So they are like scale in parallel, the capacity of the battery and the volt amps. And this is very important because the beefier the inverter, in general, they will be consuming more power at the idle. So if you go smaller, then you are going to be more conserving with your battery power. So as you can see, it is a self-contained unit. We've got a battery and the inverter. It is beefy in metal case. Here we've got our screen that is going to be displaying all the critical information. That unit is providing emergency power to network cabinet that is pulling like a 100 watts. So it was designed to provide a really long runtime. On top of our unit, we've got a massive fan that is thermal control, and it's going to be off when the transistors are cold. Here we've got absolutely beautiful battery disconnect isolating switch. This should be mandatory on every uninterruptible power supply. And I believe on a lot of APCs, you can have like a plug that can be pulled for shipping, and you can de-energize the circuit. And here we've got our output with a French socket, and our input is using exactly the same connector. This is an uninterruptible power supply, so it's got integrated battery charger and inverter and transfer switch. So I will energize our battery and press the power button. And as you can see, nothing is happening, and I deeply believe that our battery is totally dead. It was cooked by being online for many years. So let's open it and take a look what we've got inside. Since here we've got a hardware power switch and display, there will be a wire that is interconnecting it. And here you can see it. So we have to press it and pull just like that. Here you press it and it's nicely releasing. And now it is free, and we can take a look what we've got inside. And inside we can see a beefy transformer and our inverter circuit. We've got a nice thermal control switches for the, looks like for the fan. Very nice. The battery disconnect. It is a Dino rail mounted. And here we've got a massive 55 amp hour AGM battery that most likely it is totally dead, but we are going to be checking it out. So let me probe it. And we've got 6 volts, so most likely it's going to be sulfated cook. I can see something that is happening here. Definitely we are going to be removing it. We've got the nice beefy wires. Let's see. We have to undo it. You can see a design problem. Here I've got insulated wrenches and I cannot access it because it is too close to the battery terminal. This is absolutely horrible. So we have to be like an idiot and do it like this. It's got absolutely horrible design because to remove those screws, we have to hold it. So you have to basically remove it totally from wall just to extract the battery. Here is our horrible battery. And when I go like this, I can hear that something is rattling inside. So most likely the cap's vented. And yes, it is a piece of garbage. After removing that, our device really looks beautiful. So yes, this is a really sexy unit. Just take a look how much steel we've got here. And what we can put inside for today, I will replace it with a lithium iron phosphate battery. You most likely going to be asking yourself question, can you use lithium iron phosphate battery as a drop-in replacement? And it depends on the configuration. From my observation on buffer power supplies that are being recharged from 13.8 volt float voltage, you've got absolutely no problem in recharging those batteries almost to 100%. And that's because here you've got like your cut off fully charged voltage at 14.6 volt, and they do not need to be fully charged. If you've got the voltage a little bit lower, there is going to be absolutely no negative effect. You are most likely going to be improving lifespan of your device. This is not battery that have to be fully charged. This is not going to be sulfating. So the lower voltage is absolutely no problem, and you are going to be losing like a margin, tiny amount of percent of the capacity. In general, for uninterruptible power supplies that are going to be run with a full load in a small form factor, the BMS is going to be your limiting factor. Here we've got 20 amp, and 20 amp times 12 volt is going to be giving us over 200 watt of power, more than enough for our network cabinet. So yes, one of those batteries will work just fine with the network cabinet. If we put two, we are going to getting 40 amp, so it's going to be like close to 500 watts. So yes, it will get the job done. Then we've got our charging current, which I don't know what kind of is, and we have to check it because we don't want to burn it. And yes, we've got room for two of those, so let me rig it up for our test. I created this absolutely horrible setup. We've got my Bluetooth multimeter in the amp meter mode. And as you can see, I connected it between battery and our device. And now we should be able to close it down. Just like that. We have to plug ourselves here. We go like this. Now let me switch on my computer from the voltmeter to the ammeter. Let's change the range. We are in the amp. Let me energize the battery and start the inverter. And it nicely standard that, and we are pulling 1.3 amp of idle current, our display is nicely glowing. It's showing us 230 volt at the output, but of course we have to try it out. Here we've got my special lamp that is always used for testing. And as you can clearly see, it is working fine. And we are pulling almost 4 amp. So yes, definitely our inverter is working. Let's check the charging current. I will plug us to AC outlet. As you can see, we are reading the voltage incoming. I hear the relay click. We've got on the ammeter 0 amp. Fan kicks in. And it's recharging. Just take a look. We've got 5 amp of charging current. So we are definitely below our 10 amp limit. So yes, let me unplug it, and if everything will be correct, we are being transferred, and now the inverter is working, and we are discharging our battery. We plug ourselves in. We should be nicely transferred back. We transfer. And are we recharging? Fan. Recharging. So looks like we are going to be getting a good success. And let's check the isolation switch on the battery. And we nicely kill everything. This is what we've got. We've got absolutely horrible ghetto Frankenstein job. Question is, will it work? 100% yes. Will we add second battery? This is getting more complicated because I will have to put it into service, and those horrible jobs have tendency to last until something fail again. So most likely it will end up like this, and it's going to be protecting our network. So yeah, it is really funny. Let's try to put it back. We are assembled, ready for test. First, let me energize our battery. So we go like this. Then we plugging our load into the output socket, just like that. Then we can start our inverter by pressing that button for a couple seconds. And as you can see, it nicely boot up. And here you can see our screen at the close-up. We've got 0 volts incoming. Let me plug our main. The main is detected. As you can see, we've got a couple seconds delay. And now it clicked. And we are recharging. I can hear fan, and we've got a charge indicator. Just take a look how beautiful it is. And let's disconnect the mains. You read 0 volts. We've got the inverter, we've got the alarm, and everything is working fine. So as you can see, after swapping our battery, device is working again. So thank you very much for watching. I hope you find it interesting. See you next time, and bye bye.